Hello, everyone. Hope you all are doing great. First of all, thank you very much for tuning in with Recro. Myself, Ankita, and I'm working as a software developer at Swiggy and also a part of Recro, which is a developer focused organization where we are trying our level best every day to connect developers' aspiration to the right opportunity by working with the high growth startups like Dunzo, Swiggy, CureFit, Oran, and a lot more similar startups. So today's session is going to be on flow in the reactive world. So for this session, we have Himanshu Singh with us. So some of you might know him from his previous sessions, Jetpack Compose and Kotlin DSL. But those who don't, for them, Himanshu Singh is working with Rumi and comes with 4+ years of experience in the development industry. And also, I'd like to congratulate him for becoming Google Developers Expert. So, Himanshu, I'd like to hand it over to you now, please.
Hey, thank you, Ankita. Thank you so much for the introduction. So, I'm audible, right?
Yes.
Perfect, thanks. Thank you so much, and thank you everyone for joining in. So, I'm coming here for the third time because I actually love interacting with you guys coming up here. So, before delaying anything, let me first share up my screen. So, there is a very basic minimal PPT which I have created, and I actually want to show it. So, this is what we are going to learn today, or basically, I would say we are going to understand flow in the reactive world. So basically, I expect majority of the people who are here are actually Android developers or at least mobile developers, right? So while building an application right now, what we basically do is we design our application in a very reactive stream way right now. So I'll be talking a lot of examples would be around Android itself. But if you're in Swift or if let's say you are in JS, promises are there and stuff, right? I'm not pretty sure though again. So I'll be talking about Kotlin Flow, Kotlin uh, coroutines, and the streaming with Reactive JS like RX Java. But before that, first let me introduce myself. I am a Google developer expert in Android, the platform. I am a speaker for last 3 years. I've been blogging a lot. Yeah, I built a couple of open source SDKs, and on a professional front, I work as a senior Android engineer at Rumi. So Rumi is basically a US based startup, which is there for room rentals and platform bookings, right? So that's pretty much about me. We can discuss that about me later. But now, first, let's understand the agenda of this talk. So I'm not going to keep it as a typical office meeting thing, where we are going to first discuss the agenda of the meeting and then we are going to discuss कि हम क्या करेंगे आज. But it's more like agenda of the talk. So first, we are going to discuss the specific problem we have, right? That what exactly we wanted to do with the whole platform system, the reactive stream, why did it come into the picture? Then we are going to see how coroutines and Kotlin Flow actually solves it for us. Second, as a senior engineer, what I actually look into people when they actually come for any interviews or something, that they just don't know how you have to use coroutines or you have to use Kotlin Flow. What I also expect people to actually understand how they are designed, or maybe let's say how they're internally designed, right? So that's something we'll be discussing here as well. And lastly, a lot of applications currently have been built on RX Java 2.1 may be possible, and now RX 3 is also coming up, right? But I'm also going to explain you guys how you can work towards migrating your RX Java code into your Kotlin coroutines and Flow, correct? So that's pretty much it for the agenda here. Now, I'll start off with a very basic problem first. So you guys might actually understand what synchronous execution means. So when I talk about this, everything is built into two different segments. A segment of code is called synchronous, and a very good way to do something is called asynchronous. So that's the two principles which we follow on Android, right? Or maybe any programming generic knowledge. That's what we have been doing currently, right? So that's what we do: synchronous execution, asynchronous execution. But let's understand first what is a synchronous execution. So let's say that we are doing a task, correct? But if you have to complete that task now, and another task is dependent on your previous task. So let's say the first task, we name it as A, the second task, we name it as B. So when we complete the task A, then only the task B can execute, even though if it's not dependent upon each other, right? So that's an execution of a synchronous way. Or maybe the physicist or the physics world calls it the series execution, correct? Series basically means one after the other. So that's a synchronous way. So basically, the task B gets dependent if the task A is completed, correct? It's more like task A is blocking the execution of task B, correct? So take this example first. When let's say you have to do a login in your login screen, then what you step up first, you give your username and password, and after that you do that login, correct? That's a basic way. Now let's say that you have done that specific login here, right? And when you do the login, after that you get a token and a user ID. So now, as a next step, what you need to do is you need to get the user ID from the successful response, use that user ID to fetch the user details, correct? So if in a very hindsight, if I have to explain you this, the first step which we did was login. The second thing which we had to do is we had to get that user details which we actually fetched, logged in, right? So that's a way which we need to do, right? So understand this. There is a very good drawback, if I have to explain, of doing a synchronous execution, right? Now consider this: when we are doing that fetch user ID detail, it is executing only after the login is being successful, correct? So that's basically blocking our main screen. Now let's say this is a very uh, like expected task or a behavior which you need to do, that you need to first do a successful login, then you can do the fetch user detail. But let's say there are two different tasks which are not dependent upon each other. But even though if we do a synchronous execution, what actually happens is the first task gets completed, then only the second task gets executed, right? But in any case, both of them are not actually dependent on each other, right? They can actually run on a parallel execution. So that's a drawback. It takes your time, a lot of time, right? And it takes a lot of time consuming code. It may be or may not be block your main thread. So what we are very much concerned about in our application, that it should not block our main thread, right? Third, it can be like it can decrease your performance. So let's say that if you have to do a lot of API calls, and while doing that API calls, if it takes a lot of time, it might decrease the performance, and due to that performance, a lot of users might actually drop out, correct? So that these are basically a what do you say, that an exception. You might get a network on main thread exception error or some other things. So these are the drawbacks. So due to all of these, we got a very new or amazing thing, which I actually feel is amazing, is asynchronous execution, right? So when we do an async execution, what it actually happens is it executes two different tasks, task A and task B, if they're not dependent on each other, on let's say a parallel thread or different threads or asynchronously, whatever you want to say it, right? In a very basic way, if I have to explain it, it means that it explores or it runs on the background thread and it doesn't block your main thread. So if your main thread is not blocking, no exception would come up, correct? Just a very basic example of an async operation is uploading images of a user onto the thread, right? That's one. So let's talk about what are the basic options which we can use in Android for asynchronous programming, correct? So a very internal thing is called thread. Thread is so low level that it is available on your Android ecosystem from API 1. You can use thread. You can use it to do a lot of API calls, uh, doing something on a background thread or a worker thread. You can get the results back and to and fro using what do you say, that loopers and handlers. You can work with threads, right? Then we have something called RX Java. If I ask you guys, RxJava would be one of the important things uh, a lot of Android developers has been using right now, right? Before coroutines, yes, but coroutines is still picking up. So still everyone's code, almost everyone's code would have RxJava there, correct? Now, the third one, and I definitely agree, it's everyone's favorite, which is the asynchronous task, async task. I agree that it has been deprecated, but it was love of your life, right? Everybody used to use async task because it used to give us a callback saying that do this in background, do this in post execution, and all of stuff, right? So this is definitely uh, what do you say that everyone's favorite. Last, this is my favorite. This is Kotlin coroutines. So I love this part. Having Kotlin coroutines in your application makes a lot of things easy, correct? So these are a couple of options. You can still use a lot of different executions as well, options as well. But these are most widely used things when you use to design an Android app, correct? Now, let's come to the topic. We are here to discuss Kotlin coroutines and flow, right? But first, to understand flow, you need to understand coroutines. So it's basically like a synchronous execution that to understand flow, you need to know how coroutines work. So now we are into the synchronous world of understanding flow. Just joking right now. So first, let's understand what is coroutines, right? Like how, let's understand first that coroutines, what is it? So uh, coroutines is basically a very lighter version of thread, if I have to put it in that way. It helps us do asynchronous executions and it doesn't increase a lot of memory for our application. So let's say that if you're running 1,000 threads, your app might run out of memory. But if you're running a million coroutines, you might not, because it is so lightweighted that it hardly matters, right? So it's basically it doesn't allocate a new threads coming up again and again when you use coroutines, but it reuses the thread again and again. So it basically internally, if you have to feel it, it uses the thread pool executors, like that thread pools. So that thread pool contains a certain set of threads. It sees which thread is available and uses that thread to and fro to work around it, right? So this gives us a very simpler execution to do a concurrent or an asynchronous task without managing threads on our end. So that is why Kotlin coroutines is definitely better. So one of the reasons why I said is better, right? Let's say that we were doing this, right? We had a username. We did this login example. We fetched the user details. So this was our synchronous task, right? Let's say that if we have to do the same API call or like the same execution in an asynchronous way, correct? How would you do it? So now you need to end this suspend modifiers. Now, just don't focus on suspend as of now. I'll be explaining this to you. But let's say this, we had two different functions, right? Do login, where we had username and password, and we had fetch user detail, which actually took the user ID from the do login function, correct? That's basically what we had. But if you see, this is the first step if you have to convert that execution, synchronous execution, in an asynchronous way. So we added that suspend modifier. Now, if you see this here, what we need to do is we need to launch the whole execution, the suspension basically, which we created in that function. We need to launch it. So to launch a coroutine, we use something called a scope. This would also come in future, but yes, for now, bear with me. This still looks like a synchronous code, correct? This is basically a synchronous code again. We are doing that do login and we are using that user ID to fetch the user details. But this is not running synchronously. Like it in that launch container, it does asynchronous code. So we are going to understand that in detail first. But let's first understand what is a suspend function, like a modifier, let's say, right? So it's pretty similar how we add something, an overridden thing or something like that, right? So it's to make any function to run on asynchronous way in coroutines, we use this suspend modifiers, right? So basically adding a suspend modifier, this suspend them the functions instead of blocking it. So when you run these functions now, they are in a suspension state and not in a block state. So they would not block your main thread, right? So this keyword actually helps us to run that execution. So just to give you a very basic idea, a suspend can only be called. So if you have to call this function, right? Just let me navigate back this to suspend function. Just to give you a very basic idea, this suspend function can only be called from another suspend function, or it would be called via a scope. So if you remember this scope, right? This is used to call this suspend function to login, and this is used to call that fetch user details, correct? So a suspend function is called from a suspend function or another scope. So we understood both ways, right? So now let's understand what is a coroutine scope. So coroutine scope is nothing but it's just a container, or let's say that it's a scope container where you want to run that coroutines. So it basically says that you are restricted to use your suspend function only here. So consider this. In RxJava, if you recall it, if you guys have worked with RxJava, this is something like subscriptions. So it basically helps us to understand the life cycle where this coroutine or this suspend function is actually working and when it has to be cancelled, right? So this scope would run your suspend functions inside a certain restrictions. Let's say that there are a couple of uh, scopes available. So a couple of them, let's say that when we use a context in Android, right, we use an application context. That means it runs throughout your application with a single instance. Similarly, if you want to do something like that with coroutines, you have a global scope. If you want to some function which has a life cycle only when the view model is active, you have view model scope. Then to attach it to a life cycle of a view, we have a life cycle scope. So we don't have like a very high learning curve, if I have to comment that way. But just a suggestion if I have to give, don't use global scope anywhere and everywhere, right? As the name actually suggests, it works around the global scoping, and once it's created, it destroys only when the app is killed, right? So these are basically the scopes, and when it is attached to a life cycle, so when the life cycle is killed, that coroutine scopes also gets killed, right? So that's how a coroutine scope is, and that's how it uses us to run a suspend function. But okay, now we actually understood. So okay, sorry, if you guys have any questions right now, if you're not understanding anything, please definitely ask, right? But uh, I'll be taking majority of the Q&As later, but if there's something which you want me to repeat, please drop on the text. I'm definitely reading that out, right? So now we understood the Kotlin coroutines. We understood a lot of things which actually worked, right? But now what we want to do is we want to see how is this magic happening, how this code which looks synchronous but doesn't work asynchronously. So we also need to understand that part, right? So let's go ahead and understand that. I actually created this line. I actually liked it. So you are basically suspended. So if you see, the suspend is actually responsible for converting it to a asynchronous execution. So let's see our user login function again. So how we were doing the login and how we are fetching the user details. Correct. So it is basically like handling via a synchronous execution. But what is happening? What happens here is, let's say that do login executes, and then the fetch user details gets executed, right? Even if you write in a very basic way that if you click a button and when you do this login fetch calls, then it executes in a synchronous way, but we wanted to do it in a synchronous way, correct? So now what I want to do is that I want to understand what happens exactly here. When we do this login method, we get that user ID, and when this login happens, it returns a user ID, correct? So that's a very basic idea, correct? But what happens here? What this suspend function does, that it actually executes one after another in an asynchronous way. correct? So let's understand that. So when a suspend function is actually killed, or let's say that is decompiled in a JVM way, right? You would see this function converts into a very basic function, do login, and at that point, it also adds another parameter there known as continuation, correct? So this would look like a very basic Java function do login, and it would have another parameter called continuation. So let's understand what continuation is, right? So after the compiler works, when it got a computation is nothing but a callback. I would have to say, right? So it's like an interface which has two different things. It has a context and it has a resume with. So first let's talk about what context is. So this is way different from the context of activity context or application context. This is the coroutine context, which actually says like when this specific scope or the coroutines actually need to run for any state or errors, right? So this is the context which defines where it has to run. And then there we have resume with. So when we have a resume with, it tells us what kind of result did we get, correct? So when you come up with resume, it says that if it's successful, do this. If it's failure, do this, right? It's basically computing. So if you remember again in Kotlin, if we do a basic API call, we create a resource class which has three different states, a sealed class or enum, something like that, which says either we have what do you say, a success state, a loading state, or an error state, something like that, right? Here as well we have something called resume state, and which tells us what value it is passing, a failed state, a success state, something like that. So in a very basic way, suspend modifiers get decompiled having an extra parameter called continuation in the function signature itself, correct? So this continuation is helping us to understand what to do on the next step. Now, coming up with Kotlin 1.3, or maybe in Kotlin itself, when we have extension functions, right? So what it also does, it attaches two different exceptions, right? So if you see, we have resume with. So in resume with, it handles a state, a error state or a success state. But if you know, we have to do a lot of API calls regarding that, correct? We have to do when the state is result.success, get that data, or when the state is result.error, we get that data. But with extension functions coming up, we created two different extensions, not me, but basically the Kotlin way. It has two extensions which say resume and resume with exception. Now, what resume does is this thing, what it does, it tells that, okay, your execution was successful, now moved on to your next step, that's it. But let's say that we got an error, right? This resume with execution of the corresponding coroutines, it basically tells that you got an exception, this is your exception, take this exception and work through it. So we can actually feel this, right? This coroutine continuation actually works like a callback style, which has two different things. Resume, which you can consider as a success state, and we have a failure state, which you can consider the resume with exception thing, which we use, right? So everything actually works in a very exceptional way or a different way, a callback style, but that's something we don't have to take care of. That is the compiler, the JVM compiler actually is taking care of for us, right? So this is the coroutines and how it is doing it, right? So before that, let me give you a very overview what the benefits of coroutines are, right? If you are, let's say, considering to build any application right now, that application, what you want to do, what you wanted to do, what are the benefits if you want to use coroutines or RxJava. Let me give you a very basic example. So if you're using Kotlin, I presume you are. So coroutines comes bundled in a very lightweighted library. So it's very lightweighted. You don't need a context switching overhead because it's handled by the suspend keyword, which we have. We don't have to write a lot of code for that. So it's just that you launch that scope, you launch the lifecycle scope, something like that, and we don't have to do a lot of boilerplating code. And one thing I definitely have to say, the coroutines are very easy to understand, right? So these are the benefits we have. Now, understand this. With coroutines, it's a one-shot thing. So when I say it's a one-shot thing, it means do an API call, get that response, forget it. But there are some times when you have to say that you want the stream of data to flow, right? You want that. That is where you use certain operators in RxJava, right? That operators comes with Kotlin Flow, and it doesn't comes alongside coroutines. So coroutines, uh, it's more like in RxJava, it is like more of a single and a completable call, that you have completed a certain set of execution and that's it. But let's say that if you have a location coming up and you want to use that location stream coming up again and again, so at that point, what we want to do is we want to use flowables in Rx, correct? So that is where Kotlin flows in. So this is a way where we are going to use the stream of operations coming up, and this is going to use we are going to learn right now. Now, people have actually said this. Coroutines is a replacement of RxJava, correct? But when I have to say this, coroutines is just that threading model of RxJava. But a complete replacement of RxJava is when Kotlin Flow and coroutines work in conjunction, and it becomes together, right? So that is when coroutines and flow become a replacement to Rx. Now, let's understand what Kotlin Flow brings on the table. Kotlin Flow, first, it's null safe. Definitely, yes. It basically means it can't send a null value unless and until you specify it to, right? It can be used with other reactive stream libraries, correct? We'll be discussing how we can do that in a further video, further slides, right? You have definitely amazing operators. Let's say a map operator, a completable on start, a lot of different things which we have already there. Filter is one of them, which I definitely like personally. And this is one of the features which Kotlin Flow brings, and that's best. You don't have to worry about handling the back pressure strategy here. So the back pressure is something when the rate like of the producer is very high and the consumer can consume a lot of data at a time. That was which we used to handle in RxJava. But Kotlin Flow actually handles it under the hood, and we don't have to do any operations around it. So basically it's handled internally, and because of that suspension, right? If you saw that continuation and a lot of things. Now, this is a hype, Kotlin multi-platform. Every other person is actually taking up Kotlin multi-platform. It's speaking about KMP, but for you guys to know, Kotlin coroutines and Flow actually support KMP out of the box. So this is one of the very basic explanations, if I have to say, of Kotlin coroutines and Flow. So we actually understood till now the basics of coroutines and how it is being built. Now let's discuss about the Kotlin Flow and its basics. So if you see, we have a function called numbers. I'm just giving a very basic rough idea if I have to say. We used flow off. If you see that, flow off is basically a builder. It builds a flow, and this emit is used to emit the values, correct? So here, function of numbers is actually returning flow of numbers or integers, if I have to say it that way. And in return, we are returning flow of, we built a flow and we emitted 1, 2, 3. Now, to use that, correct, to if I want to get that 1, 2, 3, what I'll do is I'll do numbers dot collect. So this is the best part. When you apply a collect, then only the stream comes up. So so this emission would not happen unless and until a collector is started, correct? So that's a very basic idea how coroutines has been working and with flow, correct? Now we are going to discuss that we have RxJava here. We want to convert an RxJava code to flow in a very basic way. But if you see this numbers.collect, just keep this in mind that we are going to understand this on a later stage, but there's nothing much more than this, right? If you remember, we had something called observables, just 1, 2, 3, and subscribe, and it used to emit 1, 2, 3, correct? Similarly, in flow, if you have to see, it is flow of 1, 2, 3, and we need to collect that. So flow of is basically a builder which is used, or which helps us to build a flow of numbers. It can be flow of strings if you want to pass strings there. It can be flow of anything you want, right? Now, since we discussed the basic idea how flow works, so if you see this collect, correct? In this collect, what happens is basically it collects all the streaming of data again and again. It collects 1, 2, 3, and it moves on. So whatever the flow returns, the collection happens here. That's it. So now, giving you again an idea, we need to discuss the internals. So we basically understood how coroutines is built, right? It basically decompiles into JVM. It has a continuation callback. Continuation callback has two extension functions again. Let's understand the Kotlin flow. So let's first see the interface flow itself. So if you remember, we had a collect here, right? Collect having a function which is returning a lambda. So here we have an interface of flow. It has suspend functions there. Public suspend func collect. That's the collect which we were using to get that data. Now, if you see in that collect function, you have a flow collector again. So now let's see what flow collector is. So flow collector is a function which has another function called emit, correct? So if you see this, we have an interface called flow, which has a function collect. Then we have another interface called flow collector, and we have a function emit. Basically, flow is built upon these two interfaces. One is emission, another is collection. That's it. Like, no rocket science, no big thing. But what basic things is happening is the best part happening here is this emission. If you see this emit function, this is a suspend function, and this collect is also a suspend function. So if you want that directly, I'll just call that function. It won't work. So to run a flow, or let's say that if you have to get that data from a flow, you you actually need to run inside a scope or a coroutine scope or a function or a suspend functions, right? So basically you have to use it inside a coroutine scope and flow. Now that's a pretty much overview how flow works. That's how flow has been built upon. Now let's actually see one of the important topics which we have now, and maybe some of you might actually ask a lot of questions around it. And I'm also going to show you a very basic example how flow works with an API call alongside this, right? So you guys might have a lot of code into RX Java 1, 2, maybe 3. And now you want to actually migrate this code from RX to flow with coroutines, correct? So consider this API call. We have a fetch people API call, correct, which takes 3 parameters as query params. One is a page size query, and if you see the return statement, it is observable response and it returns a list of users, right? So no rocket science, it's for RX Java. Now you need to convert that. First you need to add the suspend keyword there, and you need to also remove the observable which we had, this one. Now it would just return the response and list of users, correct? Now I'll be explaining you via the repository pattern. So I'll have a repository here. I'll create another function which would return a flow of something. Okay, and now in that implementation which we used to have for observable, it was fetch people, which used to return observable response list of users. We just used to return that user API service class and dot fetch people with the required query params. But if you see in the flow part, what we are doing is we are having a fetch people function which we created in the repository. We are returning response list of user, which is a type of flow, And now we are building the flow. So to build that flow, one was flow of which we showed. The another builder of flow is flow. Inside that, we are emitting the user API dot fetch people, and we are passing the query params, whatever required. And we are flowing that on the IO thread or the dispatcher IO thread. There are a lot of different options as well that you can run uh, it on the default thread, on the main thread. I am choosing IO thread because to an API call or a network fetching call, we should actually use an IO thread. So here, if you see this, we return a flow, which is basically a sort of DSL, right? If you want to understand DSL, there's a link in the chat if you want to go. Inside that flow, we are returning that specific value, right? User API dot fetch people with the required query params, right? So now it returns a flow, and the value of that flow comes from this. And lastly, we are flowing it on the dispatcher IO, right? Now, the next question which people might ask is how we are going to get that data. Now, consider this is my main view model. For example, to run this, we are going to call view model scope, this one. I'll do the launch here. Now, I'll get the catch and the collect, correct? So this launch is responsible for having the life cycle of this fetch people only and only for that specific view model. If the view model is killed, your API fetch people won't work because the termination has happened already because it is running inside the scope of a view model. Now, this catch, it is also an operator provided by Flow. So let's say while executing an API call, we get some sort of an error, an exception. So it gets caught here. So inside that catch block, we get our error or the exception which we have. Then we have this collect. So inside this collect, unless we press collect, the data stream won't start. So when we do collect, we start getting our users list here. So that would come as a response for the users. So that's it. Like that's how you do an API call if you have to do anything with Flow. So just to give you an overview again, a basic recap, we first launched that function inside a scope which we used view model scope, correct? Inside that, we used our API helper dot fetch people function, and then we put two things, catch and collect. Inside that catch, we'll use let's say that error block where we get some sort of exceptions, and then we use collect block where we have some sort of responses which are coming, the successful response. That's it. Now we are going to discuss a very not commonly used, I would say, flow bindings. If you see, there are libraries called flow bindings, or there are libraries called RX bindings, where a click listener of a button is also converted into observables or something like that. So we are going to discuss something which we can convert into flow and how we can do it. Correct? So now discussing this, you might have used add text change listener where we passed the text watcher callback and you did something there, right? On text change and blah 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 blah, anything, something you did, right? Now what I want to do is I want to create a flow function which returns a flow of string. You get that, right? I don't want just to use it everywhere, so I created an extension function, right? So this is first see this, I wanted to return flow of string, right? So I created an extension function, right, which was add text change. It returns the flow of string. Now we have a callback flow. So a callback flow is responsible for converting a callbacks or a lot of interfaces methods into a flow. So inside that callback flow, we pass the add text change listeners, right? If you see that, this whole part, right? Add text change listeners, and we did that. Then we implemented its three functions after text change, before text change, and on text change. So if I'm not wrong, we do all the operations in the odd text change, right? So what we do is inside that callback flow, if we want to get that string, what we do is we use this offer, correct? So now here you see this @callbackflow.offer, and we are returning the strings which we are getting, which we are typing on that specific edit text. And when this whole operation is done, we basically close this whole listener, this listener. So basically, this is how you can actually convert add text chain listeners into a flow, into returning a flow of string. So to give you a recap of this, we first use a callback flow to convert a callback into a flow. Then we pass on that data using offer. We are using here offer. And when the task is done, we actually close that listener. We pass, basically, we nullify it if we have to go via that way. So that's what we do to convert a binding. Let's say that if you want to convert something into a click listener, let's say into a flow. So there as well, you have to open a callback flow first. You have to add a text set on click listener, and then there as well you have to use the offer, right? And then you need to close it. So that's how you can convert that as well. So you can convert a API call, which I showed you how to convert that into an RX into a flow. You can also convert callbacks into flow. So that's how I've been doing. Now, the last topic for this is Kotlin flow as data holders. So I'm not saying it would replace data classes, but if you remember, we have been using live data to update the value, get the latest set of values from API, and then we return it to the UI thread, correct? It's basically data holder for us, right? But with live data, there are certain issues coming up, like it bounds with the Android platform so much that you can't use in a very Java way. So when I say a Java way, you can't return live data from a repository. It's an anti-pattern. People came forward and said that you should not use live data with any Java or a Kotlin class. You should only use for an Android class like view models, like activity files, but don't use it with, what do you say, that repositories or API calls or interfaces, right? So uh, that is why we would be using Flow. It is basically uh, low level stuff which you can use with uh, Android, which you can use Kotlin, which you can use with Java. So it's basically a low level stuff which you can be used with any platform. And that is the reason it is supported by Kotlin multi-platform, because it doesn't require you to have only and only Android platform. You can use it with any Kotlin platform, right? So it basically does nothing. It just emits a value and collects a value, right? So to understand that, we have something called Stateflow, right? So we are going to actually use Stateflow as a replacement. I would say I would go this step ahead and say that you can use Stateflow as a replacement for live data. So if you are planning to replace your live data with Stateflow, definitely you can use it. Or let's say that if you're building a pure Kotlin project, if you don't want to use live data, you can still use Stateflow there, right? So the execution happens in a very similar way how we used to do for live data, that we used to create a mutable live data and we used to return a immutable live data. Here as well, we create a username variable of a mutable live data. Now here you can see we have an empty value, an empty string. So there's a catch with mutable Stateflow, that initially it requires a default value to create a mutable Stateflow, right? Now, second, we would return a Stateflow, an immutable one, which I don't want users to edit, right? The only addition can be worked via the mutable flow. So, and we return here the username. That's how we have been doing with live data, where we create a mutable live data here, and then we return a live data of string here, right? Now, if we want to set a value, what we do is we used to do in live data username dot post value or value is equal to something like that. I can here use username dot value in the mutable Stateflow, and I can pass on the data. And let's say that in the view file, in the activity of the fragment, I can just use view model dot name, the name here, and I can just directly collect. So if I collect that value, I would start getting that string. So here I've used Android worldwide. You can use anything here. So you can get uh, that value coming up here. So the consumer, like let's say the activity or the fragment, get that value, the latest value which we have set here inside our view file, right? So it works on the concept of a very unique operator which we have been using, distinct until change. So it only returns the updated value as it filters out the same value, right? If you have that same value, it would not return it, or maybe in our case it would not emit it. But let's say that if we get a new value again, it would emit it again and you can get the latest value. But if it's the same value, it would not keep on emitting itself. So it works on that principle of distinct until change operator, right? So Stateflow basically becomes let's say active as soon as we create it, because it's hot in nature and we pass on a default value there. So first it gets collected with the default value, and it would not be created unless and until it would not be emitted, sorry, unless and until a new value is set there. So first this username would have a default value string which would emit itself as an empty value, but it would not emit itself again unless and until the value is changed, right? So Stateflow is always active, I would say, right? And it is in memory, and it becomes prone to garbage collection only when there is no reference from its root. So this is basically a brief if you want to convert your flow, or let's say live data, into a flow itself. So anything and everything can be converted into a flow. So this is how Stateflow works as a data holder if you have to come up with a replacement of live data using flow. So to summarize this, like the whole talk which we did, right? Kotlins and coroutines and flow work in conjunction. So basically they love each other. Flow can't work without coroutines, right? That's one. It supports Kotlin multi-platform, KMM out of the box, which we actually explained. When we integrate this, it doesn't impact your size as much as some other libraries might. And at last, at least try this out. Try Kotlin Flow and you would understand why Kotlin came into the picture and why it became a better option for people to use it. So a lot of different companies are using it. We at Rumi actually migrated everything from RxJava to the Kotlin coroutines and flow. So definitely it's a must try and you guys should try it out. Um, Thank you so much, everyone. This is my Twitter handle if you want to actually connect over there. I would be concluding my talk here, but I'll be taking a couple of Q&A questions. And if you want to connect, that's it. Thank you so much.
Okay, so that was great, Himanshu, and I've shared your Twitter handle link with everyone in the chat.
Thank you so much.
And now we do have questions in the question
Yep.
section.
Mhm.
So, will you be taking it
Yeah, I'm
like
going to
with the
take it.
maximum upvotes?
Yeah, no, so I'm going. So I don't see there are a lot of questions. So I'll be going from the below to the up. Yeah, basically the time thing. So which were the latest? Since stateflow is hot in
Okay.
nature, so do we need to call collect for its emission? Yes. So if I showed you this last example, right? Just let me show you again. You need to collect it, right? So if it's emitting something, you need to collect it for as well for the values, right? So I hope that answers it. Mukesh has asked, how can we get set the observers to mutable state flow inside activity or fragment? Set the observer. I didn't get that. But if you want to say that, if you want to set a value to it, then this is it. So if you, let's say that we'll create a function, set username, we'll create a function, we'll see username dot value is equals inside that function there, and we'll set that value. So if that's what you want to ask me, if how we can set it from inside. So let's say that in a click of a button, we'll do view model dot set username, and we'll do that function in the view model. That's how we can set it. That's another.
Sorry to cut you there, Himanshu.
Sure.
Mukesh, if your query hasn't been answered yet or we didn't understand your question, you can raise your hand and we'll allow you to speak.
Yeah, please.
You,
Then we
you,
have advantages of flow in case of event listeners. So if you're saying that it's a callback listeners and everything, basically it returns a flow. So you can do a multiple operations. It runs on an execution thread of a background or worker thread. So it doesn't run on the main thread itself. So that's the best part of converting any listeners or callbacks on flow, that you don't have to execute everything on your main thread itself. Now, is Stateflow lifecycle aware like a live data? So a Stateflow is never okay. So if you got this wrong, if you see, we used a launch scope, right? The view model scope. So it scopes to that part. If you want to make it lifecycle scoping, then you have to use lifecycle scoping dot launch. So it doesn't, your uh, state flows or your flows doesn't get aware. It's basically scoped to the lifecycle scoping components. Let's say lifecycle scope, let's say view model scope or global scope, anything. It gets scoped there. Now, will global scope work like application context through activities and fragments? Yes. So when you run a global scope, it runs uh, on one thing. So basically, once you run it, it would be active unless and until your application is closed. So yes, it runs like an application context, that if you initialize it in application context, it runs throughout your application and your application skill. So avoid using global scopes. Is coroutine scope valid till activity lifecycle? It depends if what scope you're using. It can be lifecycle scope, then yes, it's valid till activity, or your view lifecycle scope. So it actually depends. Will the coroutine scope get destroyed even if you use view model to control the configuration changes? Will the coroutine scope? It depends again. See, there are two types of scoping if I have to consider that way, right? There is, let's say that your use case has a view model and an activity or a fragment. Your fragment would have a life cycle scope. Your view model would have view model scope. So when your configuration changes, the data which comes up, right? It comes up from your view model side. So view model doesn't create itself. It's a data holder which you're using, right? Live data, or let's say you use a Stateflow. It holds your data there, correct? But what do you say that? It doesn't have to get destroyed because the data comes up from your view model. So view model still has the data. So if the configuration changes, you get that value. Where is it? Will the core will global scope cause memory leak? If you're not clearing it, yes, it would lead to memory leak. You need to make it as a job and you need to cancel it when it's done. Uh, Actually, I have literally no idea if I have to say that hibernation thing in ORM library. I'm so sorry for that. So Manish has a question: when should I use data class and when should I use flow? See, these two things are very separate, if I have to say it that way, because data class is something which holds your data in your Kotlin file or in an Android file, right? Data classes are like an holder. Flow is considered as a library which helps you to do certain tasks asynchronously. So these two are different principles. So yes, you can use data classes to hold data, but it does nothing apart from that in data classes. But in flow, if you're getting a stream of data, you can do a lot of operations there. So you can't relate both of them. Shivam has a question. Can we use I missed it. Oh, sorry. Can we use multiple scopes in view model? Yes, you can use view model scope again and again if you want to call. If you want, you can create a global view model scope in your view model, and you can use that itself. It's up to you. Your call. Should we make getter and setter in data classes as we have to make member public? I feel it's not safe. See, it depends again. What you want to do, what you want. See, by default, if you don't put the private variables or the members, it is not exposed. But let's say that if there is some sensitive information, you should not expose it, right? And if you want to get it, just put, let's say, a get function of that data class. How you used to do in typical Pojo way of Java, that you can use. So there's another question. Would you explain a little more about how suspend functions are working and what would happen to the current thread which is calling the suspend function? Okay, so let me go back quickly. I'll give you the diagram flow to understand you much better. I'm so sorry, this is a lot of threads. Yep. So if you see this, right, when this suspend function, do login function, gets decompiled, basically it comes up with this continuation. This continuation is a callback, or consider it as a new parameter of your function on the JVM side of your code. Okay, so this continuation, consider it as, let's say, not interface. Yeah, okay, let's say that's interface. I'll explain it in very layman terms. So this continuation has resume with or a context. Let's not dive into context. It's basically that context where this has to run, right? But let's say we talk about resume with. So if we have two suspend functions, or let's say even one. First, let's talk about one. If we have a resume with call, it would check if the result, this result thing, if you see here, right? It would check if result is successful or not. If it's not successful, it would throw an exception. If it's successful, uh, it would go to your next suspend call if you have it. If it would do something else, for example, right? So considering this example, consider this. We had these two extension functions, right? Resume and resume with exception. So if you have used a switch case, what does that happen? In switch case, you have a value and you match that value with the cases, right? So here as well, we can do this, right? When result, and let's say that is result dot success, Yola function you have to call. If it's result dot error or failed, you have to do this. So basically, what would happen is, let's say that this two functions, right? Do login and here. Let's say by any chance, if do login fails, it would return an exception. So if you check that is in this launch, if it returns an exception, that means it doesn't have to go next, right? So now, okay, so if you have to see this, do login has an error, it would not go next, it would not go and call an API. So it's basically like a state machine. It manages the state that it's a resume with a success, then do this. If it's a resume with error, don't do this. So it's a condition check that if do login function returns a failed state, don't call fetch user detail. If do login function retains a success state, do call this. That's it. That's how that management happens. And you asked me about what happens on the thread, right? So that thread would be used unless and until this whole launch function is there or the launch call is there. Once it's terminated or the execution inside that launch happens, this one, that would be in life, and or else it would move into an unused state. Now, Saurabh has a question saying, what is an option of doing parallel API calls? Yes, you can do an API call. There are operators like, what do you say that? Zip operator is there to do a parallel API call. Also, if you want to actually check, you can go to my GitHub. There is a very good project I have made using Jetpack Compose though, but it has a lot of execution of Kotlin flow. So you can see there how it has been used. Zaki Alam has asked, in a Kotlin way of programming, developers used to use a lot of scopes. What's your view about it? Shall we use scopes on main view activity fragment as well? See, if you have to use a scope, the function definitely has to be a suspend function. If it's a regular function, it makes no sense to call any type of scope because it's an overhead of calling a lot of scopes and managing it if you're not using a life cycle or view model scope. But if you have calling a coroutine scope or let's say a global scope, you need to still manage it, correct? So I would say still it makes no sense of using n number of scopes. If the use be, use it. If there's no use, don't use it. I have another question saying, how does thread switching happens when suspend function is being called? Is suspend running in separate thread? It runs on your background thread, like on your worker thread, I would have to say that. So a thread switching and suspend function happens differently. So if this is executed, right, the value which you get, right? Sorry, I just missed. Yeah. So that value which you get from your do login function, you get that value, you get that user ID. It goes under scope. So this is working in a same thread switching mechanism. And when you get that fetch user detail inside this function, you are doing basically the scoping of launching another UI thread updations. Let's say that you update your name. That's how it happens in this part.
I think we're done. Or maybe we can wait like for just 2 more minutes. If
Yeah.
anyone has
So
any
there's
questions, we can
another thing
pause.
which I got in the chat. Rangaswamy asked zip as in JavaScript. I'm actually not sure about JS. So sorry. But zip is basically an operator which helps us run two different set of flows parallelly, if I have to put it that way. So I don't know how in JS happens, but maybe someone can help us in the chat. So I think I'll share one link. I actually like that one when you have to learn uh, flow. I created a couple of times back. Like, check this out. This is a repository which I created months back, a year back maybe. It has all the practical use cases if you have to see in that way, that a series execution, parallel execution, and that way error handling, a lot of operation works. So Mukesh, I have posted a link if you want to actually check it out. That should help you a lot. And give me a week. Actually, I'm also creating a series of videos on this flow. So I'll be hosting that on YouTube as well, so you can learn it. So I hope everyone understood that it didn't went too fast. I actually thought it went. So
So I believe we won't be having any more questions now.
okay,
So we can conclude here. Yeah. So it was really nice talk, Himanshu.
thank you
Thank
so
you so
much.
much. And I can see that our audience also loved it. But you can give us your valuable feedback on the link that I've shared in the chat. I'll share it again.
Sure. I'll actually give. Maybe I'll after the talk I'll share the link with you. Maybe you can share them.
Sure, we'll be sharing the presentation also with all the attendees.
Sure.
And along with that, we can share the rest of the links as well. Okay. So thank you so much, everyone. You all have been a great audience. And we'll soon come up with another session.
Thank
Bye
you, everyone.
bye.
Bye bye.